Hi, I will cover the introduction part. The semiconductor plating process is a critical part of ensuring product reliability, electrical performance, and long term durability. At Infineon technology, surface treatment and thin electroplating are used to improve shoulderability and corrosion resistance of lead frame for SSOP and DSOP packages. The process involves multiple stages such as chemical dipping, stripping, water jet cleaning, plating, rinsing, drying, and annealing. All of that must be carefully controlled. Even though the process is highly automated, it still depends on equipment's performance, chemical stability, and effective waste management. During the discussion with the engineers, several operational, technical, and environmental challenges are identified.
Assalamualaikum, my name is Farisa Farhana. So I will continue with the objective of this industrial virtual visit. Through this virtual industry experience and interview session, we were exposed to real operational practice in the plating and manufacturing industry. This project helped us to understand the plating process flow, machinery, safety procedure, chemical handling, waste management, and also environmental control while applying theoretical knowledge learned in our class to actual industrial operation. Other than that, it also provides valuable knowledge sharing from industry engineers and workers, build professional communication skill, and offer us insight into potential internship and career opportunities related to the course.
Hello everyone, my name is Fadumo. In this part, I will explain the process flow diagram or BFD and how the equipment works at Infineon Technology. This diagram shows the overall process starting from raw material input until the final semiconductor product is ready for shipping. The arrows in the diagram show the direction of the material flow from left to right. At the beginning of the process, the raw material, which is the lead frame, enters the system. This is shown on the left side of the BFD. So the lead frame first go to the receiving and incoming quality control area, IQC. Here, the materials are unloaded and inspected. The purpose of this step is to check the type, quality, and condition of the lead frames. Only lead frames that meet the quality requirements are allowed to continue in the process. So, after inspection of the lead frame, move to the chemical cleaning unit. This unit is represented in the BFD as a tank. So in this step, the lead frames are dipped into the heated chemical solution. The purpose is to remove dirt, oil, and mold flashes from the surface. The temperature and the chemical concentration are controlled to make sure the lead frames are cleaned properly without being damaged. So next, the diagram shows the rinsing process. Cleaning water enters the system and wastewater leaves the system. This step is important because it removes any remaining chemicals from the lead frames. You can see from the arrows that unit has both input and output streams, which is clearly shown in the BFD. Uh, After rinsing the lead frames, go to the drying unit. Here, heat or hot air is used to remove moisture from the surface. Drying is very important before plating because water on the surface can affect plating quality. On the leader frame are dry, they enter the thin plating unit. In this equipment, the lead frames are coated with a thin layer of tin. This thin plating improves uh, soldability and protect the lead frame from corrosion. The BFD shows the plating solution input and the flow of lead frames through the unit. So after thin plating, the lead frame is moved to the annealing furnace. In this step, the lead frames are heated to about 155 degrees Celsius. Uh, Annealing helps to reduce internal stress and prevent the formation of thin wickerings. The improves uh, this improves the reliability of this semiconductor products. Next, the lead frames go through the final inspection. This unit is shown as a quality control block in the diagram. So here workers inspect the lead frames using visual tools and magnifications to detect defects such as scratches and even plating or contamination. Only lead frames that pass this inspection are accepted. So after inspection, the lead frames are sent to the packaging area. They are packed, labeled, and prepared for shipping. This is the final processing step inside the Infineon technology plant. Finally, of the right side of the BFD, the finished semiconductor products leave the system. This arrow represents the final output that is delivered to the customers. Um, in conclusion, this process flow diagram shows how Infineon technology uses a well-controlled sequence of equipment and process. Each unit plays an important role in maintaining product quality, safety, and process efficiency from raw material input to final product output. Now I will focus on the equipment used in the process at Infineon technology as shown in the process flow diagram. Each piece of equipment plays an important role in ensuring product quality and process efficiency. So the first one is receiving. Uh, the process starts at the receiving section. At this stage, lead frames arrive at the factory and are unloaded carefully. The materials are checked for correct type, quantity, and any visible damage during transportation. After receiving, the lead frames are recorded and prepared to move to the inspection stage. So the next part is incoming quality control, IQC. Next, so here are the lead frames are inspected before entering the production. Operators check the lead frames for defects, correct markings, and overall conditions, and also only lead frames that meet the quality requirements are allowed to continue to the next process. So this is the next part, is chemical dipping. After IQC, the lead frames go through chemical dipping. In this step, lead frames are dipped into a hot chemical solution. This process helps to open and remove mold flashes and surface contaminants. It ensures the lead frames are clean and ready for further processing without causing damage. So the next one is A2 process. During this stage, unwanted A2 blatting and remaining mold flashes are removed. The lead frames are treated in the A2 solution and then cleaned using water to ensure no residue remains. This step prepares the surface for uniform plating. This is the five equipment. So it's called plating. After surface preparation, the lead frames move to the plating process. In this stage, the lead frames are coated with tin. Tin plating improves uh, soldability and protects the lead frames from corrosion. Proper control during plating ensures good product quality. So the next stage is annealing. Annealing process, the lead frames are heated to about 155 degrees Celsius after plating. This heating process reduces internal stress and also helps prevent thin whisker formation. Annealing improves the reliability of the final product. So now let's go outgoing quality control, OQC. After annealing, the lead frames undergo outgoing quality control. At this stage, final inspections are carried out to the check for the defects such as scratches and even plating and contamination. Only lead frames that pass this inspection are approved for packaging and delivery. So the last one is shipping. So once approved, the leader frames are sent to the shipping section. This product is packaged securely, labeled correctly, and also prepared for transportation. Proper handling during shipping ensure the lead frames reach customers safely. Finally, these are some of the final products produced by Infineon Technologies. So the main products include copper lead frames and nickel lead frames, which are used as the base materials in semiconductor packaging. These leader frames provide good electrical conductivity and mechanical support for the devices. So further addition is the finished product is also include semiconductor packages such as like SSOB and DSO packages. These packages are commonly used in electrical devices and applications where compact size and reliable performance are required. All these products are produced through controlled processing, inspection, and packaging to ensure the meeting Infineon technologies quality and reliability standards. So that is all for my part. I will pass for the next presenter.
Thank you to the previous presenter. Now I will be presenting about occupational safety and health practices that is implemented in Infineon technology. So OSH plays a critical role in ensuring a safe environment for employees. So the aim of OSH is to prevent workplace accidents, occupational diseases, and equipment-related hazards. So during the talk with the representative from Infineon Technology, the OSH practices that is implemented by the company were observed to assess its commitment towards workplace safety. As the company has only recently begun its operation, no occupational accidents or major accidents have been reported until now. The first practice is OSH inspection and monitoring. The company has established a structured safety monitoring system to ensure compliance with OSH standards. So the team of occupational safety and health, TOSH, in Infineon Technology is designated to construct an inspections every Thursday to check that machines and equipments are working within regulated safety limits. This inspection can help in identifying potential hazards at an early stage. The second step is competency and license management. In ensuring the machine can operate safely, the company strictly controls the competency of its operator. So the machine operators and engineers are required to possess valid licenses related to their job scope. They also have to renew their license every 12 months. So, which significantly reduces the risk of human error and unsafe practices. The third one is safety training and induction. So all employees undergo safety induction training before commencing work. The induction program introduces employee to workplace hazards, machine operation procedures, emergency response action, and general safety rules. So these measures are taken for every new employees that has just been assigned to their task. This ensures that employees are aware of potential risks and understand the importance of following protocol. So continuous awareness of safety procedures helps cultivate a strong safety culture within the organization. The fourth one is PPE, which is personal protective equipment. The aim is to minimize exposure to workplace hazards. So employees are required to wear safety equipment such as helmets, safety shoes, gloves, and eye protection depending on their assigned tasks and work areas. So the consistent use of PPE acts as a critical barrier against injuries and enhances overall workplace safety. The next safety measures that are taken is safety signage and hazard communication. So clear safety signage and warning labels are installed around machineries and especially hazardous areas. So these signs are especially crucial to be seen obviously inside the laboratory where the representative's main area of work is. So these signs serve as constant visual reminders to workers about potential dangers. Next is emergency preparations. Although until now no emergency incidents have occurred, the company has implemented basic emergency preparation measures such as fire extinguishers and emergency exits. So emergency procedures are established to guide employee and appropriate actions during emergencies, ensuring quick and organized responses to minimize potential harm. And lastly is accident record and safety culture. So since Infineon technology is still in its early operational phase, no workplace accidents have been reported until now. So this positive safety record reflects the effectiveness of preventive OSH measures implemented by Infineon technology. Employees are encouraged to report unsafe conditions to supervisors or the OSH team, TOSH, promoting proactive risk management and continuous safety improvement.
Hi, in this part, I will continue to talk about the problem faced in Infineon technology. First of all, we know that process stability and chemical control are important in the plating industry to make sure the high product quality and also safe operation. But for your information, issues such as equipment failure and chemical buildup can affect plating quality and production efficiency. For example, one major issue identified is the blower in the plating section. Okay, so this blower function to remove remaining chemical solution that stick from the lead frame after one processes. And over time, crystal can build up from the electrochemical process itself and can clog the blower. As you can see in the image, blower was placed right before the belt going to the next stage tank. If the clog did not remove fully, it can reduce airflow and causing improper drying. So that's why contamination can occur because chemical from other tank drip or fall into another tank. So to address this, Ms. Nabila said, regular checks and maintenance need to practice daily in every shift before production line operated, including daily blower inspection, routine cleaning of air ducts and nozzle, and scheduled removal of chemical crystal to maintain process stability, product quality, and also operational reliability.
Thank you, Farisha. So I'm going to talk about the second problem, which is oil contamination in tin plating bath. So the one major technical issue in the plating industry is contamination in tin plating bath. Oil can enter the bath from mechanical components such as pump, pipeline, and moving parts during the continuous operation. Even a very small amount of oil is enough to affect the plating solution. When the oil is present, it creates a barrier between the lead frame surface and the plating solution, resulting in poor thin adhesion, uneven coating, and surface defect. This defect often causes rejection during outgoing QC, which is quality control, especially for the SSOP and DSOP packages. Currently, leaching is used to remove oil and restore chemical balance. However, leaching requires downtime and increases operating costs. Therefore, our group recommends installing a filtration system to continuously remove the oil and find impurities. This helps stabilize the plating bath, extend chemical life, and reduce the defects. The third and final problem is wastewater treatment and chemical disposal. During the electroplating process, It uses a large volume of chemicals, and this chemical eventually enters the wastewater stream through rinsing and disposal activities. As a result, the wastewater contain high chemical oxygen demand and metal content, which must be treated before the discharge. The one major risk is the pipeline leakage or incorrect disposal, where untreated waste may mix with the treated wastewater. This increases the load on the wastewater treatment plant and requiring more manpower, time, and operating costs. To reduce the environmental impact, the company plans to adopt greener chemicals such as citric base or the organic base or the pre-dip solutions. These chemicals are easier to treat, safer for operators, and reduce the COD, making the wastewater treatment more efficient and environmentally sustainable.
To put it in a conclusion, the virtual industrial visit to Infineon Technology Sendirian had provided valuable exposure to real industrial practices in the plating and manufacturing industry. So the project successfully helps in understanding theoretical knowledge from mass and energy balance, course with practical applications through the study of process flow, PFD and PNID, interpretation and equipment functions from receiving until shipping. The discussion on individual equipment enhance understanding of how each process stage contributes to product quality, process efficiency, and overall production reliability. In addition, the company's OSH practices reflects a proactive approach to workplace safety. So, supported by regular inspections, personal competency control, safety training, PPE science, and all that. All right. So the identified operational problems, including blower blockage, oil contamination, and risk management challenges, highlighted common issues in the plating industry, while the proposed solutions highlighted that there are still solutions in every problems. Overall, this project achieved its objectives and provided meaningful industrial highlight that is beneficial for students' academic development and future engineering careers. That's all.